First off, you all know about this here, right? Did we talk about this already? Juno is currently orbiting Jupiter, and they hope to go back and look for life on the moons of Jupiter. So to be safe, anything we send up into space could have organisms from Earth on it. So what they're going to do is they're going to, at the end of when it's looked at all it was supposed to look at, it's got all these instruments on board, so it's measuring all this stuff. When it's done with its job, they're going to send it plummeting into Jupiter, and it's going to disintegrate under the high pressure and temperature of Jupiter. Because if they didn't do that, maybe it goes off orbit and it crashes into one of the moons, and if we find life on that moon, maybe it was because we crashed that damn thing into it. So we want to make sure that we find life, everybody understands it was there. So they're going to send it slamming into Jupiter. It's kind of neat. You guys remember, what do you guys know about Comet Shoemaker-Levy? You're like, yeah, you're the geek here, dude. You can spell, maybe, Jeff? There it is. You guys know about this? Anybody know about this? I can't remember when it happened. Let's see.
Oh, yeah, I remember.
When Shoemaker-Levy collided into Jupiter?
Yeah. We can see it.
Oh, my gosh. I'm sorry. that was uncalled for, Jeff.
Explosions are expected later this week.
Of miles, and was over 1,000.
Now what really, so here's the animation. What really sucked is that it crashed into the side of Jupiter that we can't see. So we couldn't actually see the crash happen. So all we got is, we have animation of it, and then we have the after effects of it. Anyway, sorry. I'm going way off on a tangent now. But, all right, so that's one cool thing I wanted to tell you about, was to make sure you all knew that we currently have an active mission orbiting Jupiter, collecting data that we've never gotten before. Oh, look at that. Smash! And we're all like, oh, thank God that wasn't us. Oh, wait, let's see this. This is cool. Smash! Down there, see this? Smash. All right, sorry. All right, that's enough of that. That's enough of that. So if you're interested in that at all. This, Desmos.com, is like a free online graphing calculator. So if you have access to the internet, you can go on here, and it's kind of cool. Now watch. If I did, let me say f of x equals 3 to the x. All right, that looks like what we'd expect it to look like, right?
Sure.
3. Yes, Jeff. I don't appreciate that tone. So that should be something I should feel comfortable saying. You guys have to know the basic shapes of graphs beyond just, it makes a U. Yes, good, you know parabolas. But anything to the x power, you should know what it looks like, right? And this is why they talk about growth or decay in this section, because that's what these are used for. What I want to show you is, what should it look like if I do 3 to the x plus 2?
Shift 2.
Well, no, 3 to the x plus 2. Right, so it'll go higher, right? And currently on this green line, where is the asymptote?
On the negative side.
On the... What is the asymptote here?
On the x-axis.
X-axis, beautiful. So if I did 3 to the x with a plus 2 sitting next to it, everything goes... So the asymptote would go up 2. I like it. So if I do g of x is f of x plus 2. The purple line now. See that? So now look, if I look back this way, see the asymptote now is up 2. Here's the asymptote now. If I zoom in a lot, you'll see, let's see how far I can zoom in. Whoa. Whoa. There, look, the little separation, look at that. How much did I had to zoom in a freaking lot. So this never touches that line, but it always gets closer and closer and closer, right? That's the idea of an asymptote. So even though on our level it looks like it's there, it's touching, if you zoom in enough, you can always zoom in so there's separation. Infinitely. Holy shit. Okay. So that's one little thing. Somebody help me out. If I put in here x squared plus y squared, oh shit, where am I? How do I recenter? Oh, scheisse. There we go. God, I was way the hell in there. If I put in here x squared plus y squared equals 9. X squared plus y squared equals 9. What should that look like? No. A parabola would be, give me an example of what's a simple parabola.
X squared.
Give me the most basic parabola. Give me an equation for a parabola.
X squared equals y.
Yes, y equals x squared. How many of the variables are squared? One of them. So if I have one variable squared, it's going to be some kind of parabola. Parabola. So y equals x squared is a parabola like this. What do you think x equals y squared would look like?
Oh wait, this was on the homework.
Oh shit, yeah.
But I forgot what it looks like. It's like.
So y equals x squared
What is
is a parabola like this. Why is it a parabola like this? Because if x is 3, it's the same answer as x of negative 3, right? If I had x equals y squared,
You're right.
yeah, now it's going to be like this, because now if y is 3 or negative 3, it's going to have the same. Oh, so it just turns everything around. And in fact, you could think of it, what did I really do here? I switched the x and y. So that's sort of like, it's not a function though, is it?
No.
But it's still a valid thing to graph. It's a relation. It's not officially a function, but I can still talk about it and graph it. Right? In fact, if you in pre-calculus, you're going to graph stuff like this. There's an equation for that. Spirograph. Oh, thanks, Jeff, for that. Maybe I won't take. Oh, come on, now, come on. All right. So now, let's talk about what we just talked about. So x equals y squared. There you go. Get out of there. G of x. Go on. Oh, Jeff, what the hell did you just do?
X.
Oh, shit and a half.
On the side of the box.
There we go. Okay. Sorry, it's just it's an exception. It's the keyboard from 1970, which you're a little freaky. All right, so that's just the parabola that way. What about x equal negative y squared? It would be parabola this way. I like it. So, a very simple question here. How do I find the vertex for this? How do I find the vertex for that?
Complete the square.
Minus
Only if I ask you. Good Lord.
negative 2a over 2a.
Yeah.
And this will give me the vertex? No, it won't. It'll give me the piece of it, right? So it should be 6 over 2.
3.
And then I plug a 3 in and get the other, right? So I get 9 minus 18, negative 9 plus 2 is negative 7. All right. So what do you think is going to be the difference if I have one of these sideways opening parabolas, like that? So what if I had x equals y squared plus 8y minus 5? How would I find the vertex? You ready? You ready? What was the equation here to find the x piece? X equals negative b over 2a. So here it's going to be, don't overthink it, it's going to be y equals negative b over 2a, that's all. So I'm going to graph this equation in a minute. Let's figure out what the vertex is. Negative 8 over 2. Then you plug, now to find x, I plug the y value in. Do you see, that's still the same idea. It's just a little, we got y first this time. Who cares what you get first? I got the second piece of the vertex first. Plug a negative 4 in, I get 16 minus 32 minus 5. Yeah, negative 16 minus 5? Negative 21. So let's see what if that is the vertex. Let's see if Jeff knows what the hell he's talking about. What did I say? X squared plus 8y minus 5. Look at that. So what was x? Negative 21. Kick ass. In fact, if I click on it, negative 21, negative 4. So the nice thing to take away from that is, just because it opens this way, the basic processes don't change really. It's just that when it's with the x in here, you get the x piece first. But when the y's in there, you get the y piece first. But you use the exact same idea, thank God. Because in all actuality, we could have, it doesn't matter which way I call up and down, and so, we could have done everything sideways from the beginning. So the variables don't really change the process at all. I don't know if you guys, all right, maybe. So there is a little bit about these sideways parabolas in that section 13.1. Some of you guys have hit that already. But I mean, they have a few examples, and it's not really that different from the up and down parabolas. I like it. All right. So I like that little side trick we just took. So coming back to my other question. Oh shit! I gotta actually. Well, I need a. I need a film student or something now. So you face that way, but x squared plus y squared equals 9. What would that look like now that we know that it can't be a parabola? Why can't it be a parabola? Because both variables are squared. Cool? So what the hell would that look like? Circle. So think about it this way. Let me ask you this. Can you give me 2 positive numbers that add to be 9?
4.5.
Or non-negative numbers. So I get it started. Like 9 plus 0, right?
Yeah.
What else?
8 plus 1.
1 plus 8, 8 plus 1, so forth. All the way down to 0 plus 9. Is that cool? And of course all the freaky ass decimals in the middle too. Alright, I really want this to make sense. When there's a plus here, do you see how this is contained? I can't go past 9. If I wanted to make this 10, why couldn't I? Why couldn't I let's do something we can actually see. Why couldn't I make x equal to 4? Why can't x be 4 up here? Think about it. If x were 4, what would this piece be? Oh shit, well you should really. I'm doing more up here than I thought I would. Alright, if x is 4, this would be 16, and I have to add something to it that must itself be positive to get 9. Is that possible? No, good. What I'm trying to tell you is, why does it make sense that it looks like a circle? Because it's contained. Neither one of these can get beyond, what's the biggest x could be? 3. Yes, sir.
Did you ever use absolute values and stuff like that?
I mean, yes, but not with what I'm talking about right now. Yes, okay. If you were solving for something, yes, you could in the middle somewhere, sure. But that's not what I'm doing. Good. Does that make sense? The biggest x could be is 3, and what's the smallest x could be?
0.
No. What else makes? Why is the biggest x could be 3? Why is that the biggest it could be? Because that would be 9, and that would make this 0, right? Because if it itself is 9, it doesn't need any help to become 9. It's already 9. Does that sort of make sense? You guys kind of with me? I'm over-analyzing circles for some reason. It's because it's going to help us understand ellipses and hyperbolas a little bit better. So the biggest x could be is 3. What's the smallest x could be? Well, what else do you square to get 9? Negative 3. Now what about y?
It could be.
It's the same story, isn't it? Yeah. So the biggest y could be is 3, and the smallest could be is negative 3. So that at least explains it's contained. It can't go outside of there. The minute one of them tries to go outside, the other variable goes, I'm becoming freaking complex, and we don't want that shit. We only graph in a real plane for this course. So I really want you to understand, complex numbers do exist, but when we graph stuff, we're graphing it on a real plane. That's why I can't let complex numbers come into play. The bigger picture is, totally I can make this be a complex number all day long, but then the graph would be freaky as hell. I have to use fractals and stuff, and who knows what else, and use colors to represent how complex things are. Holy shit. So we're not going to go there. We're going to keep the real plane. All right. How are we doing? Okay? Okay. Now, I'm talking on a bigger level, and we're going to drill down to the details in a minute. But that's why anything that looks like x squared plus y squared equals anything will be a circle. This is why. It can go the same amount in both directions, and it's contained. So it's going to look like a circle. I like it. So what would be different than if I did this? So that's a circle. And by the way, what's the center in the... Oh, Jeff, that's good. That's good. That's golden. amazing. I love that. So who can tell me what's the center of this circle?
0.
0.
Be more, I mean, a point. It's got to be a point, right? 0, 0. Because it hasn't been moved anywhere, right? And what's the radius?
3.
3. I love it. And that's based off of the Pythagorean theorem. And this like a squared plus b squared equals c squared. Well, now it's like a squared plus b equals r squared. So the r is 3. All right, let me let that soak in. If you weren't here yesterday, we investigated that equation a bit, and that's where the circle equation came from. So what would happen if I did this? And then we'll look at it there. Now think about it for a minute. Can somebody come up with what the biggest change would be?
That you could have a number that would be bigger than 9
For what? For what?
for x.
Well, for y. Right? Now remember, what was the biggest y could be up here? 3 or negative 3, right? If you want to talk about like positive, negative. So here, if I made y 3, I would get 9 divided by 9 is 1. Couldn't it be bigger?
27.
Yeah, well, what do you divide by 9 to get 9?
81?
81. So couldn't y could be up to 9. Okay, I really...
What about x squared? If you
yeah, see, no, x squared still is the same. So what can x go from to? X can go from negative 3 to 3. Because I haven't done shit to him. He's got the same problems he did before.
if it's 3, power 2 is 9, plus has to be 0.
Exactly. So when I say what's the biggest and smallest x could be, I'm letting y be an extreme. How small? What's the smallest y squared could be?
0.
So then I would get the biggest x's. If that's the smallest, this is the biggest. So yes, you're right. If I make x either one of these, y has to be 0. I like it.
So y is 81 and negative 81?
Squared would be 81. So y is anywhere
Negative
from...
9 to 9.
I like it. Now think about it. Would this still be a circle then? On the x-axis, I can go to negative 3 to 3. On the y-axis, I can go to 9 and negative 9. So what shape was that? Ellipse. I love it. So the difference between a circle equation and an ellipse equation is that the coefficient, see how this really is like 1/9 y squared? If the coefficients of x squared and y squared are different, then it's going to be differently sized in one of those directions. I really want that to make sense. Here, why is it symmetric? Because that's 1x squared and that's 1y squared. There's no difference in either way. That's why it's perfectly symmetric. Ooh, that was a good circle. Here, it's going to act differently in the y direction. Because I'm dividing by 9, the top can be bigger than what it used to be able to be. So now it's going to go farther on the y-axis. So let's look at both of these on this dude. So if I do x squared plus y squared equals 9. There's my little circle of radius 3 there, right? I want 3, there's 3 shot. All right, is that cool? All right. I really want that to make sense. Do you see how it's contained? And it's because it's plus. So we are going to investigate what if this was a minus. That would be like the next step up. Since it's a plus, it's contained. This is still a plus, it's still contained, but one of the letters can go a little further now, because first thing I'm doing is dividing, so it can actually be bigger than it was before. So now if I add that in, to make this divided by, gather. See there, now it's reaching up higher and going down lower on the y-axis because it's the y that I messed around with. Does that make sense? I like it. So why, how did I figure out that it could go from negative 9 to 9?
Because you can go up to 9 in the y side.
Yeah, this can equal 9, and to make that equal 9, y could be 9 to negative 9. I like it, right? So that's what it does there. Is that cool?
Okay, and if the x was divided by 9 instead, it would just be like this.
Yes, exactly. I love it. So if instead of the y being divided by 9, excellent question. How do I hold it? I should use this more often, but I don't. If I made this divided by 9 instead, it's just going to be, you know,
It'd be the same numbers, but
cigar-shaped UFO coming at us. Good. Or Stewie's head. All right. There you go, it's for you people. All right. So what's beautiful about this, how far does it go in the, let's look at this equation since it's the one that's up there. How far does it go in the x direction? Negative 9 to 9. So from the middle, it goes out either way 9 steps, right? How far does it go in the y direction? 3. 3 up, 3 down. So this equation here, here's the beautiful thing to watch. If I make, how can I make this become 1? Divide both sides by 9, right? So if I divide both sides by 9, this is now x squared over 81 plus y squared over 9 equals 1. Now watch this. What's the square root of 81? Since it's with the x, that's how far it goes in the x direction. Can you believe that shit? So beautiful. If it's equal to 1, the denominators tell me how far it's going to go in the direction of the variable it's with. That's silly. And it's all because of what we just did earlier. It's all because of that. What about y? Square root of 9 is 3, and that's why y can go up 3 and down 3 away from the center. And why is the center still 0, 0? Because there's no shifts in there. There's no x minus anything. Right? All right, let me let that sink in a little bit. Bless you.
Thank you. And that's because multiplicatively 3 is in between that.
So let's look at this. Since I made it 1, how do I make y squared over 9 become 1?
9.
If y is...
9.
No, if y is 9, then...
Or the y is 3.
If y is 3. So that's why the square root of this is what tells me what y can do. Do you guys see how that relates?
Yeah.
So it's sort of like saying y squared over 9 is y squared over 3 squared. So that's what y can do. Y can go up to 3 and down to negative 3 because I want this to be 1. Alright, so that's really overanalyzing, but that's basically what we're saying earlier. I like it. Alright, so let's immediately do some concrete examples of how this works. We'll do a circle real quick, and then we'll do some ellipses, because the hyperbolas have a little more explanation required. All right. All right, go in, Mr. Bill. All right, we're trying to get back. So let's do a few of these together, and then I've got a little, me, got problems for you guys to work on together. So to start off nice. Well, I was going to do a circle, right? Let's do a circle first. Let's do a circle that's been shifted.
This is a certain section.
Second?
This is chapter 13.
Yeah, this is section 13.1 still. 13.1 is parabolas and circles. I say that so authoritatively. I have no idea. Let's see. Yeah. 13.1 is parabolas and circles. 13.2 is hyperbolas and ellipses. So, don't say that out loud. Write down some key aspects of this shape.
X squared plus y squared equals
So that's the basic format of this, right? So I know it in fact I told you what it is. What is this? If I graphed it, it would be a circle. And why? How do I know that? Because the coefficients of these are both 1, right? They're both being divided by 1. They both have the exact same coefficients. So I know it's going to be a circle. It means in both the x and y direction it's symmetric. Neither one of them acts differently because they both have the same coefficient. Yes, sir.
we FOIL these out.
You good God, no. Here's why. Normally, a circle would have 0, 0 as the center. That's not true anymore. If I leave it like this, I can see the center. The center would be 1. Doesn't that feel familiar, right? Isn't that... on the side here, don't write this down. What would the vertex of this be? Become us through there.
Seven.
7, negative 2.
How is that a negative 3?
Why was that a 7? Because if it's in with the x, I have to do the opposite. How do you make this 0? If x is 1. How do you make that 0? Negative 3.
Bring the 2 over on that one.
Everything you plug in for y can be 3 smaller than normal, because the first thing I do to it is make it 3 bigger. That's why it goes back 3. I'll let that soak in. That's what we did this for, to get you ready for this. So why is that a minus 2? Because it's not with its variable. If I put it with its variable, then they would both act exactly the same, right? That becomes 7, that becomes minus 2. It's just when it's written like this, that's not really with its variable. Well, here, they're both with their variable. Just change the sign on both. That's the new center. What's the radius? 4. It's always the square root of this number. Will it always be something nice? No. So how do I graph this thing? Well, what do you think the most important thing is? Center. It's not even a point. Don't put a dot there, because then you're telling me it's a point on the graph. It's not. The points are the same distance from that center. The center is not a point on the graph. Oh shit. Does everybody understand that? Right. So what I always do when I'm going to graph this, so now I'm at 1, negative 3 for the center. This is always the most exciting part. Alright, so what I do is at the center, which is at 1, negative 3, 1, negative 3, I put a little open circle. So I'm golden. I've got a little target that I can build off of. So how far do I want to go up and down from there? 4. So I go 1, 2, 3, 4. That's a point on the circle. And then I go 1, 2, 3. Oh shit, Jeff. And how far left and right do I want to go? 4. That's crazy. So I went 1, 2, 3, 4. Jeff can count. 1, 2, 3, 4. Much better than he can draw. Alright, that's supposed to come out to be a circle. Yes, sir?
So to get the radius, you just square root the 6.
Exactly, because the basic idea of a circle is this. So if these are different, then it's shifted the middle. And whatever that is the square of what the radius is.
So there's going to be a radius that you can't square perfectly?
Yeah, it might be 11 over there, but then you just estimate it. Square root of 11 is roughly this, and then you count up roughly that. They're not going to do too many of those to you. And now you just do your best. Yeah, I don't know. Fat man. No, sorry. Wait. No? Whip. Okay, shoot. Watch good TV. If you're going to watch TV, watch good TV. Alright, how we doing there? Do you guys see how that works? I mean, circles are beautiful. You can't beat circles. They're awesome. You find the center. Now, notice something. This is the right question to ask. Will it always be written like this for me? No, it will not be. So real quick, just to remind you guys what tools we have at our disposal. So if I had this, for example, let me make it come out nice. Give me a second. Yeah. All right. I think that'll work the way I wanted to. We'll find out. Is that now? How do I know this is a circle? The x squared and the y squared.
Have the 1.
They both have the same coefficient. Again, if it was 4x squared and 4y squared, it would still be a circle because they have the same coefficient. If this was x squared and that was 4y squared, now it's going to be an ellipse. Yes, sir.
And you have no parentheses in there on purpose?
On purpose. Totally. Does anybody see? isn't this sort of like, now, does everybody understand this is the best format for a circle, right? Like mx plus b is the best format for a line because I can see all the shit about it. Right now I can't see shit about it.
So you factor.
What do you do, group?
Factor out.
Yeah, but you got to do it a special way. I need it to become something squared, so I need to figure out how do I complete what it needs to become a square. If only we had a process maybe called completing the square. I don't know. For example, that'd be a great thing to call it. All right, Jeff, stop doing that. Yes?
So we take the 4x and the 6x and try to move them over.
Oh, I'm sorry. Make that a y. That's my bad. But you're right. If it was an x, you just add those together. No big deal. Aw, who cares? You just put your like terms together if they are. That was my fault. My fault. But if it was an x, you just combine them before you do anything, right? But now there's no like terms. So what I do is I make some room. Right? Make some room. So let's see. What are the steps? Half of negative 4 is? Negative 2, so I know that's how it's going to factor. Negative 2 squared is? What's happening? We all forgot shit. We all forgot this very important thing. So the 2 steps are cut the guy in the middle in half. That's how it's going to factor. Second step is take that and square it. That's what I have to add to both sides.
So you complete 2 squares at once.
Totally. Now if I put plus 4 there, I better freaking put it on the other side. I can't add 4 to one side and not the other side. That would be crazy.